The Chinese company AI has introduced one of the most realistic androids to date named Tang Sanzang. Its appearance is inspired by the iconic character of monk Tang Sanzang from the classic Chinese novel Journey to the West, which gives the project not only technological but also cultural significance. One of the main features of Tang Sanzang is its hyper-realistic facial expressions. The robot is equipped with a complex system of micro-actuators that mimic the movement of human facial muscles, allowing it to convey a wide range of emotions, from surprise to empathy. This makes the android almost indistinguishable from a real person during close contact. In addition, the robot is covered with soft bionic skin, made from advanced synthetic material, which is extremely close in texture to human skin. This skin not only looks realistic, but also reacts to touch, enhancing the effect of living interaction. The robot also features humanoid eye movements, including the ability to maintain eye contact, track moving objects, and respond to gestures. On the intellectual level, Tang Sanzang is integrated with advanced artificial intelligence solutions. It is capable of recognizing speech, understanding its context, and holding coherent conversations with a human interlocutor. Another fascinating development by the company is the humanoid robot ELF-V1. This android, designed in the image of an elf, became a true sensation at a recent high-tech exhibition in New York, combining the aesthetics of mythological creatures with the most advanced engineering solutions. Its appearance, behavior, and facial expressions impress with their realism and expressiveness, making it not just a machine, but a character brought to life from the world of fantasy. One of the key features of ELF-V1 is its high mobility. The robot is equipped with a system offering more than 30 degrees of freedom, which allows it to perform fine and smooth movements that are very close to those of a human being. Its gestures are elegant, and the turns of its head and the fluidity of its hand movements create the illusion of a living creature. ELF-V1 is covered with soft bionic skin that visually and to the touch resembles human skin, making interaction with it feel more natural and comfortable. On the intellectual level, ELF-V1 is equipped with an advanced artificial intelligence system that enables it to engage in natural language conversation, understand the context of what is being said, and adapt to its conversation partner. The company Clone Robotics has showcased progress in the development of its eerily realistic robotic machine. In a new video, the robot demonstrates movements strikingly similar to those of a human being, twitching and bending while suspended from the ceiling. Unlike traditional robotic humanoids, which rely on rigid metal frames and electric motors, Protoclone has been engineered using more than 1,000 artificial muscle fibers and 500 sensors, precisely replicating the musculoskeletal system of the human body. With 200 degrees of freedom, the machine is capable of performing very smooth and natural movements. The potential implications of this development could be profound. In private homes, robots like Protoclone could assist people with disabilities, handle household chores, or serve as caregivers for elderly individuals. Components such as hands and wrists, legs or feet could also be used as highly realistic prosthetic limbs for people with amputations. In workplaces, they could carry out physically demanding or repetitive tasks, reducing the risk of injury for human workers and increasing overall efficiency. The Chinese humanoid robot G1 continues to amaze the world with its incredible capabilities. Recently, the company Unitree Robotics published a video showing their human-like robot demonstrating boxing skills, first sparring with a human and then facing off against another G1. Despite its relatively slow movements, limited dodging ability, and challenges with maintaining balance, G1 is already quite impressive. While its motions still fall short of human agility, the robot is already capable of recognizing attacks, reacting to them, and delivering punches. Unitree G1 is a humanoid robot standing at 1.32 meters tall and weighing approximately 35 kilograms. It is equipped with 23 degrees of freedom, allowing it to perform complex movements, including punches, blocks, and even flips. Its maximum walking speed reaches about 7.2 kilometers per hour. Over the past few months, G1 has already surprised audiences by executing spinning kicks in Kung Fu style and even performing 720-degree aerial rotations. Very soon, robots can fully integrate into everyday life, performing complex tasks and interacting with humans on a whole new level. One of the most advanced examples of this future is the female humanoid robot Imoga, developed in China by Sherry Robotics Company. Imoga is not only capable of recognizing speech in multiple languages, but also of understanding the meaning of phrases in context. The robot can already conduct complex conversations, switch between languages, and adapt to the communication style of the person it is speaking with. Imova stands at 167 centimeters tall and weighs 65 kilograms. It is equipped with 41 degrees of freedom, including 12 in each arm, which provides it with high mobility and precise movement control. Its maximum walking speed is 1 meter per second, and the maximum torque of its joints reaches 512 Newton meters. The built-in battery, with a capacity of 0.7 kilowatt hours, provides up to 2 hours of autonomous operation. Chinese engineers from Agibot and Physical Intelligence have achieved impressive progress in developing a universal control model for robotic humanoids. The system they created allows robots to perform multiple tasks while adapting to different types of commands, manipulators including grippers and bionic hands, and sensors, ranging from panoramic cameras to traditional lenses. Thanks to this technology, companies' robots have learned to manipulate objects of various shapes, pour drinks, move items, open lids, fold clothes, and carry out a wide range of everyday tasks with high precision. Every action is performed in real time, with smoothness and stability approaching that of a human. One of the most striking demonstrations of this new technology was a scarf dressing task. The robot used both hands, coordinating them with impressive dexterity and biomechanical accuracy. Before you is a new, unique autonomous delivery robot developed by the company RIVR, representing an advanced solution for the last-mile delivery stage, from the distribution center to the recipient's doorstep. One of the key features of the robot is its unique wheel leg architecture, which provides high maneuverability and the ability to overcome various obstacles in urban environments. This design allows it to efficiently navigate sidewalks, building entrances, and even staircases, ensuring parcel delivery directly to the recipient's door. The robot is equipped with advanced sensors and an artificial intelligence system, allowing it to move safely and autonomously along its route, avoiding obstacles and adapting to changing environmental conditions. It is capable of independently determining the optimal path and adjusting it in real time, ensuring timely and precise delivery. The implementation of these robots is aimed at increasing the efficiency and sustainability of logistics processes, reducing the workload on couriers, and lowering the company's carbon footprint. Write in the comments which of the robots shown in this video you like the most. Don't forget to like this video and subscribe to the channel. Also, check out our previous videos. Goodbye.